is coming from the Maliba College, and his good name is Dr. Jemish Maisuria. He has done his PhD in wireless and communication. Okay. Today, and he is a laboratory in charge of Center of Excellence, which is developed by the Bosch. And today he is going to deliver an expert session on the industrial automation using PLC. So I request all you to listen carefully. That will be helpful for your project of the automation. Okay. So I hand over the session to Dr. Jemish Maisuria sir and continue.
Thank you, sir. Good morning, all of you. Actually, nowadays, when we see everything in your real world is related to automation. Okay. One of the ad, that is of Mr. Amitabh Bachchan. Okay. You can see that he is sitting at airport and he is just giving a demo of Internet of Things. That means he is just operating his house AC with the mobile. Okay. So that's, you can say, IoT or you can say automation. Okay. So over here we'll give a demo, or you can say first we'll just see a video related to automation, because always when you learn something, and then after we'll just go for automation. Okay. Because automation is, you can say, a very big word. Okay. Too many things will be covered inside automation. Okay. When we talk about right now, whatever the automation is going on in industry, that is Industry 4.0. If you heard about that, then it is nothing but a combination of 3 to 4 technologies. Okay. Or 3 to 4 buzzwords that we already know. Okay. First, that is IIoT. Okay. IIoT is nothing but what? Industrial Internet of Things. Internet of Things is nothing but what?
Connecting devices with internet or
Giving a device an IP address. But why we are giving IP address? For accessing. Or actually, when you provide IP address to your devices, actually you are giving a name to that device. And that name is related to what? It is related to network. Because when you connect any device into the network, it will be identified by IP address, and another is MAC address. 5th semester students, maybe they learn CN, computer network subject. Okay. So in that, 4 types of addressing are there. Okay. If we talk about the layers in your networking, then 7 layers are there. OSI model. 3rd semester students will not knowing that, but they will cover in that particular CN subject. And 7 layers are nothing but what? Physical layer, data link layer, network layer, transport layer, session layer, presentation layer, and application layer. And in that 7 layers, on the 4 layers, they will just provide addressing. What is addressing? So that also I will cover in my presentation. Okay. Because we will cover some of the portion of digital electronics also, or your DLD subject, digital logic design. Okay. So when you deal with memory, you will find out 3 things in that. Okay. Data line, address line, and control lines. Okay. So we will talk on that thing. But right now, as IP address is nothing but what? It's a logical address that you are providing to your device. One more address is there, that's known as MAC address. Okay. It's a 6 byte long. Okay. When you just write in your laptop or desktop, okay, in CMD, command prompt, if you write ipconfig, okay, so it will show you a different addresses. In that, MAC address is there, IP address is there. Again in IP address, 2 types are. Okay, IPv4 and IPv6. What is the difference between that two? Just the number of bytes. In IPv4 you are having 32 bits, whereas in IPv6 you will have 128. Okay, so when you increase the number of bits, what happens? The benefit will be you can accommodate more number of users. You can accommodate more number of users. Clear? So that is IP address. So physical address, that is fixed for each and every device. If you see in your mobile, it is unique. If you see over here in this laptop, it is again unique. In my laptop, again unique. Okay, so it is only one individual. Second one is your logical address, and that is your IP address. So IP address can be unique when you are connected in a single network. But there are too many private networks. So each and every private network can have duplication. Okay, that means 192.168.1.1 can be over here at the GEC, and the same address can be over there in my college. That is Maliban, or you can say Ukatarsaria University. Okay. When you deal with IP address, again two things are there: public IP address and private IP address. Okay. However, whenever you just visit your laboratory, means computer lab, what you will do? You'll just do that. Open your Google, okay, and in Google you just search "show my IP address," each and every student. And you just write that thing. You will find out that on each and every PC you will have same IP address, and we'll have terminology that if IP address is same, then conflict will be there. But it is not over there. Why? Because for world you are a single person, and that IP address is of your server IP address. Okay, so all your data will be routed through your server. So GEC is having one server and a gateway. So all your data will go through that gateway only. And inside GEC, you are just designing what? Private network. And on that private network, you are having what? Private IP address. And that will be allotted by server. That will be allotted by server. Okay. And in that, static IP allocation is also there, and dynamic IP allocation is also there. So this is all about, you can say, communication part. Okay. આપણે ક્યાંથી જોયું? Okay, from IoT. Okay. So IoT is nothing but what? You are giving IP address. Two more address are there. So આપણે address ની વાત જ કરી. So I will give you that two more addresses are also there, and that is, another one is your port address. Another one is your port address, and that will be at your transport layer. Okay, and that is used to define one of the application in your PC. Physical address થી આપણે શું define કરીએ? Your PC address. Logical will be given to in network your PC. Okay, and the port address is a specific application in your PC. Because in your PC you are running too many things. You are running Chrome, as well as you are running Microsoft Teams, as well as sir apna open karelu WhatsApp. Okay, so too many applications are there. So how to differentiate data between them? કે WhatsApp માંથી આપણે hi send કર્યું, so એ WhatsApp માં જ receive થવું જોઈએ. એવું થાય છે કે Facebook માં receive થાય? Not possible. Why? Because each and every application is connected through one single port address, and that port address is provided on a transport layer. Okay, on a transport layer. Clear? On a transport layer. And the last address is your specific address, and that will be on an application layer. An application layer is dealing with what? User interface. User interface. And a specific address kya hai? When I write email to you, what I will give? Email address. WhatsApp पर आपने શું use करी थी? Mobile number. Facebook पर Facebook ID, Insta ID. So that ID or that address is known as what? Specific address. So these 4 types of addresses are used in your networking. In your networking. Clear? Clear with this? Now you just see this video, because in IoT, when you provide IP address, that means you are enabling that device to be communicated. Actually, આપણે એને control નથી કરતા. We are not controlling that device. But when you provide IP address, that means what? You will make it as a communicable. Okay? Make it as a communicable. પછી communication માં આપણે શું provide કરીએ છીએ? We'll provide user interface. We'll provide some sort of script that will run and that will give you the controlling output. That will give you the controlling output. But first and foremost thing is what? Communication. First and foremost thing is communication. પેલી એડમાં બી શું હતું? મોબાઈલથી આપણે કંટ્રોલ કરતા. But that controlling will be inside application. But the first thing will be what? Your data should be go from this mobile to that AC, and that can be happened using what? IP address or networking. Okay, so that is Internet of Things. Clear? So one technology is Internet of Things. Another technology is, you know the name ML. What is that? Machine learning. So can anyone tell me what is machine learning in layman language? Simple. What is machine learning? કોને આપણે કહી શકીએ machine learning? No idea. Okay. I'll give you a very simple example. Okay. જ્યારે હમણાં આપણે આ PC કનેક્ટ કર્યું એટલે તમે એક ફોટો જોયો ડેસ્કટોપ. He is my son. બરાબર? એને હું ગાર્ડનમાં લઈ જાઉં. બરાબર? So when we go in that garden, બરાબર? ત્યાં પેલા ડોગ એટલે કે કૂતરા રખડતા હોય. બરાબર? So first time જ્યારે હું એને ગાર્ડનમાં લઈ ગયો, બરાબર? ત્યારે કૂતરાએ ભાવ ભાવ કર્યું. એટલે મેં એને શું કીધું મારા સનને? See, that is doggy. બરાબર? ભાવ ભાવ. Second day also I have given the same thing to them, to him. કે ભાઈ આ શું છે? ભાવ ભાવ, doggy. Third day also, fourth day also. Okay, and on the 5th day when we go over there, બરાબર, અને જ્યારે એ ડોગી દેખાવે એટલે એને સામેથી ડેડી ભાવ ભાવ. So that is machine learning. I have provided input, okay, and trained, and once that machine is trained, it will give you the output. It will give you the output. પણ cat આવે તો એને ખબર નહીં હોય. બરાબર? કેમ? કે I have not trained that cat. જો એ બી એને હું કહી દઉં તો he can differentiate also. બરાબર? કે આ dog છે અને આ cat. But to learn that thing, what we have to do? Features. We have to provide features. So always when you deal with machine learning, over there different kinds of features are, and that you have to provide. And from that features, it will create a model and it will give you output. Either it is regression type or it is classification type. Regression that means what? It will provide you the value, and classification that means what? It will provide bifurcation between classes. Okay, whether it is dog or cat or something like that. Okay, so that will be on features. Okay, detail માં જઈએ તો ઘણી બધી વસ્તુ. One more technology is AI. What is AI?
Artificial intelligence.
Artificial intelligence. So what is that? You know machine learning. So what is artificial intelligence? It is actually the advancement of ML. Advancement of ML. Self-learning. Self-learning. Okay. So sometimes your devices, okay, or whatever your computer is there, it will learn by himself. And that's called artificial intelligence. Okay. It is somewhat like our brain. Okay, so over there neurons are, and you can train that neurons, okay, or it can be trained automatically, supervised, unsupervised, okay, reinforcement. It's a different kinds of learning, okay, you can provide to your system. So that all combination plus internet is nothing but what? Industry 4.0. So you see one of the videos, okay, you can concentrate over there, and it will give you the motivation for today's session.
A vision of tomorrow's manufacturing. Products find their way independently through the production process. In intelligent factories, machines and products communicate with each other, cooperatively driving production. Raw materials and machines are interconnected within an Internet of Things. The objective, highly flexible, individualized, and resource-friendly mass production. That is the vision for the fourth industrial revolution. A look back at history. At the end of the 18th century, the first steam engines and the intelligent use of hydropower revolutionized production. The late 19th century saw the rise of electrical engineering and mass production. The first moving belt conveyor was used as long ago as 1870 in the slaughterhouses of Cincinnati, Ohio. In the mid-1970s, electronics and IT began to expand rapidly into industry. Siemens developed the first Simatic. Production became increasingly based on computer-assisted controls. The fourth industrial revolution is still a vision. Experts believe that it will only become a reality within the next 20 years. In intelligent factories, everything is interconnected wirelessly. At the German Research Center for Artificial Intelligence in Kaiserslautern, this future can already be experienced right now. Research is underway here into exactly what the industrial production of tomorrow will be like. A bottling plant for liquids set up together with Siemens is used to demonstrate the most important components of the intelligent factory of the future. Each bottle contains an RFID chip storing a precise description of how it has to be processed. Which liquid, which lid, and which label. At each station, the bottle communicates directly with the machine, telling it how it has to be processed. At the end, a computer checks whether the bottle has actually been produced as designed. Factories with networked machines and products are already in existence today. In the future, however, these hitherto self-contained systems will be connected together in a comprehensive network. All devices, machines, and materials will be duly equipped with sensors and communications technology and connect to each other. These systems are known as cyber-physical systems. The highlight is that they communicate with each other and also control each other cooperatively. For the customers, this means tailor-made products at relatively affordable prices. For industry, it means highly flexible mass production that can be rapidly adapted to market changes. Because in the future, product life cycle will be even shorter. Another reason why it's increasingly important to depict engineering across the entire life cycle. Maintenance, for instance, is planned in from the very start. At Corporate Technology in Princeton, a cyber-physical control is being researched even today. The vision, the control, and all linked sensors are connected to the internet.
One potential scenario is enabling the PLC to react to utility pricing information in building automation. We can ask PLCs to do simulation to calculate how much to pre-cool the building with the ultimate goal of turning off the cooling system during peak times.
But that's just the beginning.
We prototype capabilities in PLC to access big data in cyberspace in real time. And we've also enabled a network of PLCs to connect to a dynamic simulation of the entire physical process.
Siemens is shaping the future of industry. Connecting the real with the virtual world of production is making it possible to enter entirely new dimensions in quality, efficiency, and flexibility. The company is well prepared for Industry 4.0.
So this is related to your Industry 4.0. And initially, they just show you the different revolutions of industries. So we'll discuss that also. Okay. This is related to Siemens. Okay. It is you are having in your college. Okay. Center of Excellence, Siemens. Okay. One more is that one more company, that is Bosch Rexroth, and we'll have the automation lab for that in our college. Okay.
Our world is interconnected. The Internet of Things and Services allows for limitless possibilities. New technologies expedite the creation of revolutionary value-adding
You can see
innovations.
the different
What
technologies.
seemed like
Okay, I
yesterday's
listen.
science fiction is today's reality. The fourth industrial revolution is at full speed. As pioneers of this new era, we at the Waikato plant operate a standardized production network worldwide. Our strategy is geared towards a digital factory. Our hydroelectric power station generates renewable energy. By combining energy and production data, we systematically improve our energy efficiency. Our digitized in-house special machine building unit paves the way for a fully connected production. The interaction with our machines is as intuitive as using a tablet. We experience our machines throughout the design and construction phase. To achieve this, we make use of virtual reality. Our holistic strategy towards a digital factory ensures the utilization of future-oriented technologies. To this end, we develop processes that will shape the world of tomorrow. The complete automation of our flow of material through RFID streamlines our logistic processes and reduces stocks. Simultaneously, we create transparency along the entire value stream in real time. We're aware of the processing status of every order at any given time. This fosters a highly flexible environment. Furthermore, demand-driven material replenishment reduces the workload of our employees. In our relentless effort to improve, we utilize automatically generated analysis and evaluations. In doing so, we can focus on what's important, the availability of our machines. Failure losses on production lines are made transparent by means of standardized visualizations and address specific target groups. This facilitates a comparison and benchmarking of our machines on a global scale. Trends and critical developments are automatically detected and reported to our operating personnel before output losses occur. We record potential error sources. Relevant video sequences are intelligently edited and subsequently analyzed. Reoccurring interferences are linked to known error patterns. Recommendations for action are derived from these patterns and enable our personnel on site to act as skilled problem solvers. Industry 4.0 also represents flexibility for our employees. Mobile shift scheduling allows a quick and customizable shift organization. In our cafeteria, we experience the advantages of digitization on a daily basis. RFID technology improves the payment process and caters for a relaxing lunch break. Our success is based on the exemplary collaboration within our network of experts. In all of this, we pursue one clear objective: ensuring the future of our plant and thereby the future of our employees. Because there are some things you simply cannot digitize.
The last demo, whatever actually we are having at our college. Okay, this is one kind of assembly line you can see, and how it will make a cube. You can see over there two racks are there. One is the black one and another one is your aluminium. So two half cubes are there. Okay, so it will first check, then it will be joined, and then after it will be put on a rack. Okay, so that type of system is there. But the difference between that video and this one is this technology is your Industry 3.0, and that one, whatever we have seen inside the video, that is Industry 4.0. Okay, so you can see Industry 3.0. See the first half view. That's it. Okay, so this actually Maya Darsaria Industrial Automation Research and Development Center. That is a name of that particular center, which is over there in our institute. Okay, and that is actually collaboratively developed by Boss Rexroth. Okay, and they provide training to some of the faculties to make them trainers. Okay, so actually over there 5 laboratories are there. You can visit. They will just arrange a visit for you by dealing with your faculties. Okay, over there different 5 laboratories are there. First laboratory is your hydraulic laboratory. Second one is your pneumatic laboratory. Third one is your PLC laboratory. Okay, PLC is nothing but what? Programmable Logic Controller. Programmable Logic Controller. Fourth laboratory is your sensor laboratory. And when you combine all laboratories, then your fifth laboratory is your mechatronics laboratory. જેનો આપણે હમણાં video જોયું. બરાબર? So in mechatronics laboratory, you will have that station. 3 different stations are there. Okay. The first station is your raw material testing station. You can visualize it is similar to your bottle filling plant. Okay. So first bottle will come, it will check, and the filling process will be there. So filling process will be on second station. That pin is inserted and that 2 half cubes are joined. Okay. And the third station is nothing but what? Arrangement station. Okay. So it will do what? Stacking of your bottles. Cubes. Okay. So 3 different stations are there over there. The same thing will be there inside industries also. Okay. But why it is industry 3.0 and not 4.0? The difference between 3.0 and 4.0 is connectivity, or you can say internet. You can say internet. Connectivity is there. Okay. But when you see industry 3.0, the connectivity is wired as well as local only. Local, that means what? Local, that means what? Only to that device specific. Okay, device specific, not more than that. And when you connect to internet, that will be the global. That will be the global. So that means your device or whatever your particular setup is there, that will be controlled from anywhere. You can control from your home also. Okay, or from anywhere you can control it. Clear? So that will be your industry 4.0. Okay, so we'll start just presentation. Out કરે ત્યાં સુધી આપણે ડિસ્કશન કરીએ રિલેટેડ ટુ ડિજિટલ, બીકોઝ ડિજિટલ ઇલેક્ટ્રોનિક્સ આઈ થિંક સો થર્ડ સેમિસ્ટરમાં બી કવર as well as fifth month already. So can anyone just give me the difference between digital and analog? Anyway, you get signal in terms of system.
Equal in terms of
Okay.
analog, it is a continuous.
Okay. કયા સેમિસ્ટરમાં છે? 5th માં. ઓકે, વેરી ગુડ.
ડિજિટલમાં કન્ટિન્યુઅસમાં હોય, ડિજિટલમાં 1 અને 0 હોય અને એનાલોગમાં દરેક પોઈન્ટ ઉપર કન્ટિન્યુઅસ આપણને વેલ્યુઝ મળે.
Okay. On every point you will get the values. Okay. So let's say suppose we'll say at the 1 second you will have 1 watt. On next second you will have 2 watt. On next second you will have 3 watt. Again 2, 1, again 1, 2, 3, again 3, 2, 1. So it is analog or digital? Analog.
એટલે મતલબ કન્ટિન્યુઅસ વેવફોર્મ છે કે ખાલી ડિસ્ક્રીટ વેલ્યુઝ છે?
It's a continuous. But you can say it's a
તો ડિજિટલ
square wave.
સ્ક્વેર છે તો ડિજિટલ.
Digital. So what is the difference? Sudden changes. So the basic difference is when you will have continuous value in your signal. Continuous value, that means what? Okay, between 1 volt and between 2 volt there is too many values. 1.01, 1.02, 1.03, like 1.1 and up to 2.99 or sorry 1.99 and 2. So with respect to time and your value or magnitude, you will have what? Continuous variation. So that will be your analog circuit. Whereas if you are having some discrete values like 1 volt is there and then after directly you will have what? 2 volts. Directly you will have what? 3 volts. Okay. It's something like quantization. Okay. So you will have steps and according to steps you will have values. It is also continuous. But in values you can't have in between values. So that will be, you can say, digital. Okay. આપણે કોઈ પણ analog signal હોય, you can convert it into digital by which? By this quantization process. Okay. આપણે જે ADC અને DAC સ્ટડી કરીએ, analog to digital converter and digital to analog converter. In that, this quantization process is there. What you will do? Whatever the range is there, you are dividing that range into different steps. And that steps is also what? It's not random. Okay. You are providing according to the bits. Let's say you will have 3 bits. Then how many levels are there? 3 bits. 8 levels.
2 raised to
Because 2 raised to 3. Simple. હવે 2 raised to 3 ક્યાંથી આવી? Somewhere 3 bits.
zeros and ones per depend.
Okay. Let's say
3 bits હોય અને 2 વેલ્યુઝ હોય. 0
I will give you, let's say I will give you number 101 in binary. So how you can convert it into decimal? Decimal तो खबर है. Decimal is what? જે number system આપણે usually we are learning from first standard, okay, which is having 10 symbols in it, 0 to 9, clear? And the binary is 2 symbols, okay. And when you are going to convert from binary to decimal, what you will do? Places को numbers देंगे, okay. Then actually it is what? Actually it is weightage. You are just multiplying each bit with its weightage. જેવી રીતે ડેસિમલમાં આપણને ખબર છે કે let's say suppose I am writing 121, so that first one is nothing but what? Unit place. 2 is nothing but what? 10th place. And The 1 is your 100 place. એ ક્યાંથી આવ્યું? It's a weightage. અને એ weightage કઈ રીતે આવે? You are just doing power of your base value. Base value શું છે? 10. અને એ જે પોઝિશન છે એનાથી એને આપણે પાવર કરીએ છીએ. ફર્સ્ટ છે 0 થી સ્ટાર્ટ થાય એટલે 10⁻0 એટલે 1 એટલે એને આપણે યુનિટ પ્લેસ કહીએ. સેકન્ડ પ્લેસ 1 છે એટલે 10⁻1 so that is 10th place. થર્ડ પ્લેસ 2 કહેવાય એનું જે પર્ટિક્યુલર આપણે ઇન્ડેક્સ કહીએ એને 2 કહીએ. so 10⁻2 so that is 100. so like that your number system is. Okay, and the same way we are doing in binary also. 2⁻0 1, 2⁻1 2, 2⁻2 4, 2⁻3 8. એટલા માટે જે કોડ બને છે એને આપણે શું કહીએ? 8421 કોડ. ક્લિયર? હવે છે 8421 કોડ. બરાબર, ડિજિટલમાં બધાને જ આવ્યું છે. Weighted code, non-weighted code, complementary code. Too many things are there in digital. And when you are in electronics, not only electronics, nowadays in each and every branch you require this. Because when you deal with real world, બધી જગ્યા પર આજે ઇલેક્ટ્રોનિક્સ આવે in mechanical also. Because when you see a Tesla car, Tesla ભૂલી જાઓ, let's say suppose આપણે મહિન્દ્રાની જે હમણાં XUV 700 આવે, too many things are there. Land detection is also there. Okay, હમણાં એક વિડીયોમાં હતું land detection. એટલે એક લેડી કાર ડ્રાઈવ કરતા અને ઓટોમેટિકલી એનું જે પર્ટિક્યુલર સ્ટીયરિંગ છે એ ટિલ્ટ થતું. સો દેટ ઇઝ land detection. And you can experience the same thing in your XUV 700 if you drive. Okay, જો એને તમે ડ્રાઈવ કરો and so if you drive, it will do what? It will detect the length, and according to that, it will just tilt your steering. Okay, and you can experience the same thing. Same way, speed control is also there, and other things are also there. Okay.
સર કન્ટિન્યુ કરો તમે ચાલુ કરો એમાં જ થશે બોલાવો થશે
Okay, so this is all about, you can say, your digital. Yeah. And in digital, if we talk about, then the main thing is your sequential circuit. Where type of digital?
Sequential and combinational.
Combinational and
Sequential.
So when you discuss about processor, so the processor is nothing but what?
Sequential circuit.
Combination
of mode. Sequential.
combination of that too. Okay. Because when you going for ALU design, એ બી તમારા એ પર્ટિક્યુલર સબ્જેક્ટમાં કવર થઈ જાય છે, બરાબર? Arithmetic and logical unit design. Okay. Your 5th chapter, or if you talk about Morris Mano, in that book, your 9th chapter is there. Processor logic design. Okay. So in that processor logic design, you are doing what? You are just designing a simple 4-bit processor. 4-bit processor, that means what? That means what? Can anyone tell me? હમણાં આપણે જે લેપટોપમાં યુઝ કરીએ એ કયું પ્રોસેસર છે? i3, i5, i7. It is 64-bit processor. So why we call it 64-bit processor? Or જેਵੇਂ તમને કીધું કે આપણે ડિઝાઇન કરીએ that will be your 4-bit. So on which thing that depends?
Input pins.
Again, you can find 3 things over there: address line, data line, and control line. So whatever the size of your data line, based on that you can give the name to the processor. 64-bit processor, that means what? It can process a data of 64 bit at a time. And 4 bit processor means what? It can process 4 bit of data. તમે જે processor design કર્યું છે, in that you are doing what? 12 different types of operation. 8 arithmetic operation and 4 logical operation. Okay, so 12 different operations are there. But your data A and B is what? Of 4 bits. Of 4 bits. Okay, so that's why it's called 4 bit processor. Okay, જે આપણે 8085 સ્ટડી કરી છે 8 bit processor, because we can perform 8 bit operation on it. Okay, so that is data line. And address line is what?
Address line can be both 8-bit and
Again, it will
16-bit.
come inside your memory. Memory શું છે? તમે જો ડિટેલમાં સ્ટડી કર્યું, can anyone tell me? Memory. I used to give a very simple example in my class that your memory is nothing but your society. Okay, it is similar to your society. જ્યારે સોસાયટીની વાત કરીએ તો એમાં રો હાઉસીસ કે ફ્લેટની વાત કરીએ તો ફ્લેટમાં શું હોય એટલે કે એપાર્ટમેન્ટમાં શું હોય ફ્લેટ્સ. ઓકે, સો ફ્લેટ્સ આર વોટ? ઓલ ફ્લેટ્સ આર સેમ કાઇન્ડ, બરાબર. 2 BHK હોય તો આખી બિલ્ડિંગમાં બધા 2 BHK અને યુઝ્યુઅલી આપણે 2 BHK ની વાત કરીએ તો આઈડિયલી એમાં કેટલા પર્સન રહી શકે? 4. 2 બેડરૂમ છે એટલે 4 જણ, પછી આપણે એડજસ્ટ કરીએ વાત અલગ છે. But usually there is 4 people. So that 4 people is nothing but what? Number of bits you can store on one location. And that location is nothing but what? It is made up of registers. It is made up of registers, not resistance. Register. Okay. And that register is made up of what?
Flip-flops.
Flip-flops. Okay. And flip-flop can store
1 bit.
1 bit of data. 1 bit of data. Clear that? Okay. So if you want to store 4 bit, you require 4
4
bit.
flip-flops.
Okay. So that one flat is nothing but what?
4
Register.
flip-flops.
Okay. Or you can say flip-flops. 4 flip-flops. હવે કેટલા ફ્લેટ્સ છે? That is nothing but your number of locations. Number of locations. બરાબર. આપણે એમ કહીએ કે ભાઈ 10 ફ્લોર છે, બરાબર, અને દરેક ફ્લોર પર 10 ફ્લેટ્સ છે. સો કેટલા ફ્લેટ્સ થયા? 10 મલ્ટીપ્લાય બાય 10 કેટલા? 100 ફ્લેટ્સ. કેટલા થયા? 100 ફ્લેટ્સ. And if I want to give number to each and every flat, and if I start with 0 0, the first flat will be 0 0. So how many numbers I require, or how many digits actually?
99.
Total 100. So how many digits? Only 2 digits. Only 2 digits. Why? Because it is decimal number system. Again, let's say the 4 flats are there, but now I'll just give the number in binary. Then 2 bits, 0 0, 0 1, 1 0, 1 1. So that is address. So address line should specify how many number of locations, different locations you can identify. Clear? So એના માટે શું define થઈ શકે? The capacity of memory that you can connect with your processor. If your 8085 processor having 16 bit of address line, how much number of memory or how much capacity of memory you can connect? 2 raised to 16. 2 raised to 16 multiplied by 8 bit, because data line is 8. Data line is 8. So that means 2 raised to 16 is nothing but what? 65536. That is 64 KB, you can say. So with 8085, you can connect 64 KB of memory. Clear? So આ concept શેનો હતો? Digital. અને આમાં મેં તમને explain શું કર્યું? I have explained you the use of address line, data line, and one more thing, control line. Control line is used for what? Either for writing your data or reading your data. Because with memory you can do that two things only, nothing else. Either you can read the data or you can write the data. એટલે આપણા ફ્લેટમાં બી શું હોય? કી, ચાવી. એનો યુઝ કરીને આપણે શું કરી શકીએ? Either we can enter inside the flat or we can leave from the flat. So entering, that means what? Writing. And leaving, that means what? Reading. So whatever the key is there, that is control. I'll use to give this example. So students will easily catch up. Okay. Here we'll go for this particular presentation. And ઘણો time આપણે આમાં spend કરીશું. That is related to digital. Okay. That is related to digital. So now just moving towards automation. Okay. So automation, that means what? We are just doing what? Machine will work automatically. Machine will work automatically. And in that you require three things. You require what? Three things. Okay. Okay. Let's say suppose humans, means you all are. Okay. You are giving exam. You are giving what? Exam. Okay. First thing, now sitting here, and the particular supervisor has given you what? Question paper and answers. What you will do first? Read the questions. क्या આપણે એવું કરીએ કે આ તો નથી લખવાનું, આ થઈ જશે, આ નહીં થાય, અને પછી આપણે કેલ્ક્યુલેટ કરીએ કેટલા માર્ક્સ થાય. If I will pass, then I will give exam, otherwise I will leave. It is not like that. First thing we'll do what? We'll scan the paper. We'll read the paper. Okay. Reading the paper is nothing but what? Providing input to your mind. And reading will be through your eyes. So your eyes is nothing but what? Sensor. It's nothing but what? Sensor. The first thing is sensor, or you can say input. Second thing, once you read that, what happens? You will try to interpret. કે ભાઈ આ કંઈક ક્વેશ્ચન પૂછ્યો છે, ભલે રોટેટ કરીને પૂછ્યો હોય કે ગમે, you just think કે ભાઈ આનો આન્સર શું આવી શકે. So that is what? Processing. And processing will be at your brain. So brain is nothing but what? Processor. Second part will be processor. And the third part, answer ખબર પડી જાય એટલે આપણે છાપી. પેલો મિસ્ટર બીન નો એક વિડિયો આવે, છેલ્લી 5 મિનિટમાં એને બીજું પેપર મળે, બરાબર, અને એને કમ્પ્લીટ કરવાનું. તો જ્યારે આપણને આન્સર મળી જાય ત્યારે આપણું બી કંઈક રિએક્શન એવું જ હોય, બરાબર, કે કંપાસમાંથી આમ બોલ પેન આપણે ફાઇન કરીને ફટાફટ લખવાની ટ્રાય કરીએ, બરાબર, કે કદાચ પાછું માઇન્ડમાંથી નીકળી ગયું. So it is what? Output, or you can say actuation. એને આપણે ઓટોમેશનની લેંગ્વેજમાં શું કહીશું? Actuation or actuators, બરાબર. So your hand and leg is nothing but what? Actuators, જે તમને આઉટપુટ પ્રોવાઈડ કરશે, બરાબર. ઇનપુટ શું છે? Your senses. Processing unit, your brain, and output will be your actuation. Okay. And in that way only your processor is also work. Okay. આપણે શું કરીએ છીએ? Read, interpret and perform. The same 3 steps will be performed by your processor also. That is what? First, reading is similar to fetching. You are fetching your program from memory. કારણ કે આપણે પ્રોગ્રામ લખીએ છીએ એ પણ ક્યાં હશે? Inside memory only. Inside memory only. So fetching that data or that program, okay, so that is similar to reading. Second, once you fetch your program, you're going to decode it. Decoding. Decode શું કામ કરવું પડે? Can anyone tell me what is decoding? Similar to interpretation, but why we require inside processing? If you learn this DLD subject very well,
machine
you will be able to
language
understand.
अपने language
Each and every machine will work on what? Machine language. Binary. Okay. And binary is used to provide what? A different kinds of selections. Which type of operation we want to perform? Out of that 12, what will be the input? What will be the output destination? So that selection will be based on that particular control word. And that control word is nothing but your instruction. So from that instruction, we'll just decode which kind of operation we means processor have to perform. Okay, so that second step is decoding and third step is execution. In our human tendency, it's perform, and in processor, it is execution. It is execution. Clear? So this way, your processor is also working. So this one is your learning sequence. Okay, we'll just see the revolution. Okay, history of automation, PLC, history of PLC, and application, and the remaining 2-3 topics, if time permits, we'll just see. Otherwise, the main thing will be what? Up to the PLC. Okay, we'll learn up to the PLC. Okay, so first, industry revolution. Read करवानी जरूर. I'll explain you in a simple language. Similar to your mobile phones. આપણે mobile phone માં भी ખબર છે કે first શું હતું? 1G, then 2G, then 3G, then 4G, અને હવે શું launch થવાનું?
5G SP.
So that is what? That is what? A different generations. અને એમાં શું થાય?
Connectivity increase time.
It will just improve the experience of users. User ના જે experience છે એને શું કરશે? Improve કરશે. In terms of speed, reliability, okay, and connectivity. One more thing, પહેલા આપણે મોબાઈલ સવારે લઈ જઈએ એટલે સાંજે ચાર્જમાં મૂકવો પડે. હવે 1 or 2 days भी ચાલી શકે. So that is battery backup, or you can say efficient use of battery. Efficient use of battery. Sir, हमारे तो 2 વાર મૂકવો પડે દિવસ. It is because whatever you are using. Okay, so industrial revolution is similar thing, starting from how industry is working and gradually how the improvement will be there. Okay, so in that your first revolution is industry 1.0, and industry 1.0 is nothing but what? Steam engine. Okay, so તમને ક્વેશ્ચન થાય સર એ પહેલા શું હતું? તો એ પહેલા જે હતું that is human power or animal power. બરાબર, આપણે ગાય ભેંસ બળદ એનો યુઝ કરતા. બરાબર, કોઈ પણ વર્ક કરો for transportation or any other work. Okay, but then after this revolution occurs and you will reach to what? Steam engine. So using steam engine, your work will be done. Your work will be done. Okay. Then Okay, this is the explanation only. Okay. Next one is your Industry 2.0. Industry 2.0 is nothing but what? Not only invention of electricity, but simultaneously the invention of transmission of electricity from one point to other point. जो ये वस्तु फाइंड आउट नहीं थे ट्रांसफॉर्मर्स जो ये फाइंड आउट नहीं થયા તો આજે આપણે અહીંયા બેઠા છે બરાબર ને આજે ફેન ચાલે છે કે લાઇટ ચાલે છે કે આ લેપટોપ ચાલે છે એની પાછળ એક આઈસી એન્જિન ઇન્ટરનલ કમ્બશન એન્જિન બરાબર એમાં પેટ્રોલ ભરીએ એને ચાલુ કરીએ એનાથી ઇલેક્ટ્રિસિટી જનરેટ થાય એન્ડ યુ કેન રન બરાબર. So think about light ni bajar, fan ni bajar, everywhere, mobile ni bajar. You have to connect it. So that revolution is very much important. Okay, transmission of electricity from one point to other point. અને એના લીધે જ આપણે શું કરીએ છીએ? Generators are there, hydro power plants, nuclear power plants. Okay, we have visited Kagra Power also. અને એમાં 3-4 સાઇટ જે અત્યારે વર્કિંગ કન્ડિશનમાં આવવાની બરાબર 1-2 ચાલે છે અને બીજું એ લોકોનું ડેવલપમેન્ટ છે 3-4. એ સાઇટ શું છે તો કે એમાં ન્યુક્લિયર ફ્યુઝન બરાબર. તો એ જે ફ્યુઝન થાય એ જે ચેમ્બર છે ત્યાં સુધી અમે જઈએ બરાબર કે જ્યાં ફ્યુઝન થાય. If you see the wall, it is this much size and metal. Okay, all 4 walls. Okay, and in that walls they are doing this fusion, and through that fusion, your electricity is generated. And we have visited for automation purpose. Okay, some inputs, some sensings are there, and we have to carry out to the control center, and through that we have to perform a work. Because when fusion occurs, after that you have to cool down that particular room. Okay, કારણ કે એની એનર્જી એટલી લેવલ પર હોય કે બહુ હોટ very hot, temperature is around 200 or more than that, so you have to cool down that. અને એના માટે એ લોકો શું યુઝ કરે? water, hard water. Okay, so how to divert that water inside that chamber, how to clear that, all that things will be automated through PLC and a different valves. A valves जो तुम्हारे जोवा है will visit, you can visit, will arrange the visit in our laboratory. ત્યાં એ same valves in laboratory, hydraulic valves. એ valves શું છે? It is similar to your ઘરે જે ટેપ છે નળ એવું જ, but એમાં difference શું છે? It is operated electrically. Electrically that means using solenoid. આપણાને કન્સેપ્ટ ખબર જ છે ઓલરેડી. સોલેનોઇડ શું છે? It is inductor, simple kind of inductor. Coil. It will generate what? Magnetic field. And through magnetic field, you will just provide displacement. You will just provide displacement. Clear? So that thing will be there. Okay. So this Industry 2.0, and then whatever we'll see, that is આપણો જન્મ થયો. Electronics and communication. Electronics and communication, that is Industry 3.0. Invention of electronics or magic of electronics. And electronics no mean कौन आंसर आपको? Main, the main thing, heart of electronics, transistors. અને હજુ ડાઉન માં જઈએ તો semiconductors. When you add impurities, then you can find what? Extrinsic type of semiconductor, and combining that you will find what? Transistors and diodes. And using that, only we are designing what? Different kinds of digital circuits. And that will be used to design processor. Okay. So back end માં શું છે? ટ્રાન્ઝિસ્ટર. હમણાં ન્યૂઝમાં આપણે જોઈએ વેદાંતા. બરાબર. ઇલેક્ટ્રોનિક્સ માટે ભગવાન થઈ ગયું. બરાબર. કારણ કે અમદાવાદમાં પ્લાન આપવાના સેમિકન્ડક્ટર માટે. બરાબર. બટ એ સેમ થઈ ગયો. એ તમને કદાચ ખબર હોય કે નહીં? ડોલેરા. ઓકે. સો ડોલેરા. ઓકે. તો એ ડોલેરામાં એ લોકો શું પ્લાન કરવાના? એને શું કહેવાય? You need to improve your reading. At least newspaper. એનો જે આર્ટિકલ તમે રીડ કરો તો એમાં બધી જ વસ્તુ આપે છે. They are planning to just start foundries, and that foundries are nothing but what? જેવી રીતે આપણી મિકેનિકલની foundries હોય, બરાબર, વેલ્ડિંગ કરીને કંઈક મશીન બનાવે, same way we are developing what? Chips, and that chips are nothing but what? IC, application specific integrated circuit. તમને એવું હશે કે અત્યાર સુધી આપણે ત્યાં એવું કંઈક બનતું જ નથી. ના, બને છે એ ખાલી અને ખાલી પોતા માટે ફોર ડિફેન્સ પર્પસ. જેટલી પણ ચિપ ડેવલપ થાય છે દેટ વિલ બી યુઝ ફોર ડિફેન્સ પર્પસ. તો તમને એમ થાય સર આપણી પાસે તો ઘણી બધી આવે છે, કારમાં બી આવે છે, ઇવન ફોન્સમાં છે, ઘણી બધી રીતે. That all things we are importing from Japan, China. Okay. That's why only હમણાં તમને ખબર છે કે CNG કારની શોર્ટેજ છે. That is due to this chip only. કે chips જે છે એ અવેલેબલ નથી એટલે એનું જે કંટ્રોલિંગ CNG એ પોસિબલ નથી. And that's why manufacturing car already prepared થઈને ત્યાં પડેલી એ લોકોના ગોડાઉન. But due to this circuit only you cannot sell it. કારણ કે ચિપ્સ નહીં. અને એટલા માટે જ મોદીજીએ એક નવું સ્ટેપ લીધું that we are developing foundries. Okay. અને એટલે જ આ foundries આવે. Electronics. Clear? And industry 4.0 internet boom. Okay. These all things you have seen inside videos. Okay. See each and everything. Take cover for it. Nice. Okay. I'll tell you. First we'll start with robotics. Downside. So video માં જોયું robotic arm, pick and place. Okay, so that is what robotics. ત્યાર પછી next augmented reality, AR and VR. આપણે વિડિયોમાં જોયું પેલા ચશ્મા, બરાબર, અને પછી એ સિમ્યુલેશન પરફોર્મ કરે. તમને એમ થાય કે એનો બેનિફિટ શું? So before developing any machine you can get what will be the output of it. So that will be the benefit. So you can reduce what? Designing cost. Because the very expensive thing is your R&D. Research and development. So that development cost will be reduced if you do simulations. Okay. So using virtual reality or augmented reality, you can able to do what? Simulations for that. Then additive manufacturing. What is that? એક વિડિયોમાં આપણે જોયું કે આખું હ્યુમનનું સ્ટેચ્યુ બનાવવું, એને આપણે કહીએ છીએ 3D printing. That's called additive manufacturing. બરાબર. એના પહેલાના ટાઈમમાં શું હતું? Let's say suppose very simple example. If you want to make a screw, આપણે જો screw બનાવવો હોય તો આપણે શું કરીએ? We'll take one rod and we'll remove metal from that rod, extra metals. અને પછી એ shape શું આવે? Screw shape. That means you are removing material. અને 3D printing માં શું છે?
Adding material.
You are adding materials. એના benefit શું છે?
Waste also.
Waste of materials. અહીંયા શું થઈ ગયું? Remove થયું. So that's why additive manufacturing. Not only in plastic industries, metal માં પણ 3D printing આવે. And nowadays બરાબર, હમણાં જ એક હેકાથોન હતું in Chennai. In ચેન્નાઈમાં એક સ્ટુડન્ટ ઇલેક્ટ્રોનિક્સનું, I think so he is in 3rd or 4th semester only, and he has designed in hackathon a 3D printer of your particular house. Okay, so concrete will be placed. તમે સર્ચ કરવું હોય તો YouTube પર સર્ચ કરજો 3D printing of concrete. Okay, 3D printing of concrete. So એને આખું એક રૂમ કે ઘર ડિઝાઇન યુઝિંગ ધેટ કોન્ક્રીટ. It takes time કારણ કે લેયર બાય લેયર તમારે એડ કરવું પડે, બરાબર, and you can make a house. Okay, so that is additive manufacturing. Okay, then simulations already there. Okay, Internet of Things, it is there. Internet of Things માં એક બીજું વર્ડ આપણે જોયો બધા જ વિડિયોમાં, that is RFID. What is that? Radio frequency identification. Radio frequency identification tag. RFID tag. શું હોય? No idea. આપણા આઈ કાર્ડ્સ હોય એના પર ઘણીવાર હોય RFID, બરાબર, that you can put it chip you. It is not exactly a chip. Okay, or ઘણીવાર આપણે ક્રેડિટ કાર્ડ્સ કે ડેબિટ કાર્ડ યુઝ કરીએ, બરાબર, એમાં ટેપ ટુ પે આવ્યું, so that is RFID. Okay, one identification is there inside your car. Okay, and that is passive type, not active type. Active એટલે શું? કે જેમાં બેટરી હોય, અને પેસિવ એટલે શું? વિધાઉટ બેટરી. જ્યારે સિગ્નલ્સ આવે, it will take power from that signals and it will provide output. So that is passive type RFID. અને જે કાર્ડ્સમાં હોય એ બધા કયા છે? પેસિવ ટાઈપ RFID. કારણ કે તમને ટેપ કરવાનું, ટેપ કરો એટલે એની જે ફ્રીક્વન્સી ઓર વેવ્સ છે એ કાર્ડમાં આવે, from that power it will generate the output and it will identify that this person is there. Okay, so that RFID is there. Okay, it's a simple coil. It's a simple coil plus a small size of memory. Okay, so that will store your identification, and from that coil it will communicate. Simple. Okay, so that is passive RFID. ઘણા મોલમાં બી હોય છે, બરાબર, આપણે પરચેસ કરવા જઈએ, બરાબર, ક્લોથ પરચેસ કરવા જઈએ તો એના પર કંઈક આવું બટન જેવું હોય, બરાબર, એને તમે જ્યારે બિલિંગ કરો ત્યારે રિમૂવ કરો, તો દેટ ઇઝ RFID. કારણ કે ઘણીવાર આપણે એમ જ લઈએ, આપણે નથી કરતા, but some people will do what? They just wear and go. એટલે જેવું એ બહાર જાય એટલે અવાજ ચાલુ થઈ જાય, બરાબર. That is detection. Clear? So that is RFID, or you can say Internet of Things. Okay. Big data. It is buzzword nowadays. Big data analysis. In your Facebook, Instagram, everywhere it is there. Why big data? Because when you communicate each devices with each other, too many sense data are there. Okay, sensing data. So that all data is nothing but what? A huge amount of data. And in that, you have to take a decision and you have to analyze. So that is big data analysis. Big data analysis. One thing, if you observe, કે તમારે Amazon પર કંઈક સર્ચ કર્યું અને પછી આપણે Facebook ઓપન કરી એમાં સર્ચ કરતા same thing will be appeared over there due to this because your each and every digital activity is observed by the person or whatever network or system is. Okay. Then cloud computing is what? Google Colab નું નામ સાંભળ્યું છે? TensorFlow, too many things are there for Python meetings. Google Colab is there. એ શું કરે છે? It will provide servers for computations. તમારે તમારો કોડ મૂકી દેવાનો અને એ સર્વર પર એક્ઝિક્યુટ થાય, બરાબર? એટલે તમારે પ્રોસેસિંગ પાવર યુઝ નહીં કરો. It will just use the processing power of servers. That is one type of cloud computing. Okay. Then after, cyber security is there. Main તો શું થાય? આપણા બેંકમાંથી પૈસા બીજાના અકાઉન્ટમાં જતા રહે. ઘણીવાર આપણે ઇન્ટરનેટ બેન્કિંગ યુઝ કરીએ તો સાયબર સિક્યોરિટી નહીં હોય અને વિધાઉટ એન્ક્રિપ્શન if we transmit the data then what happens? Everyone will know your ID and password. Okay, so it should not be there. So that's why the cyber security is there. Okay, and the last one, horizontal and vertical integration. It is like communication between devices. एक सिंपल वस्तु આપણા અહીંયા let's say college માં બરાબર કંઈ પણ એપ્લિકેશન કરવી હોય તો that is flow બરાબર કે તમારે કંઈક એપ્લિકેશન કરવી હોય તો પહેલા તમે કોને કહેશો? ક્લાસ ટીચર હેડને વાત કરો. હેડ કોને વાત કરશે? ડાયરેક્ટર or whatever the institute supervisor is there and then it will be flow બરાબર. So one hierarchy is there. Okay, so same way hierarchy is there in industries. One supervised PLC is there. Any under one which is slave PLC, master and slave PLC. Any slave PLC niche again so બીજું complex network હોય. Some PLCs are there or directly devices are connected. Okay, so that's called your vertical integration. Right? They are vertically communicated. And same way, device to device, PLC to PLC, slave to slave, master to master, communication is there. Then it's called horizontal integration. So both kind of integration is there. So combining this all technologies is your industry 4.0. Clear? Benefits, घना बड़ा है. You can read. Okay. Mass customization. Can anyone tell me? Nowadays, you can order using customization. बराबर तुम्हारे कार order करी customize करेंगे तो कार order कर सकते हैं. I want this color, I want this specification, something like that. Same thing will be with your laptops also. You can customize. So that is mass customization. Okay. Flexibility is there and other benefits are there. Okay. So this is all about summary of your industry revolution. Okay. And automation na benefits is okay. Productivity, quality and cost and as well as security. Okay, security or safety you can say. Okay. So this one is history of automation. Pehla manual work thatu, barabar. Then after you have used pneumatic, barabar. Then hardware logic એટલે કે આપણે જે રિલે યુઝ કરતા હતા. રિલે ખબર છે? how big? Something like this, and it will work something like this. Hey guys, yeah. Animation. Current flow hai, so connection will be there. There a current આપણે remove કરીએ, connection will be removed. Connection will be removed. Okay, and then after PLC will be there. Okay, so PLC is nothing but what? Programmable logic controller. Okay. बस स्टॉप करिए.
कंटिन्यू करूँ ना नाश्ता પછી.
So these are the manufacturer of one or two slides and we'll stop. Okay. Manufacturer of PLCs. આટલી બધી કંપની શું બનાવે છે? PLCs. Okay. PLC માં શું હોય? Basically this thing is there. Input, output, CPU and power supply. Okay, and you can program that PLC. For programming, okay, these are the input devices. એમાં આ digital છે એટલે કે discrete અને આ બાજુ analog. These are the output devices, again digital, analog. These are the PLC types, fixed and modular. Difference between that, fixed માં શું હોય? Fixed number of input output. અને મોડ્યુલર માં you can vary that. તમને પેલા બ્લુ કલર અને પિંક કલર દેખાય મોડ્યુલ, you can add and remove that module, so that is modular PLC. Okay. For programming you can use this much type of languages: ladder diagram, graph, sequential function chart, function block diagram, structural text and instruction list. Instruction list is similar to your assembly language. Ladder diagram is graphical representation. Okay. And block diagram is use of blocks. Okay. Ladder માં શું આવે? તો કે કઈક આ ટાઈપની અરેન્જમેન્ટ હોય. Rails are there. Rails એટલે એને પાવર લાઈન કહીએ. અને રંગમાં આપણે શું બનાવીએ? Will make a control. Okay. One of the example will be like this. કે ભાઈ એક સ્વિચ નો યુઝ કરીને એક લેમ્પ ઓન કરવો હોય, simply you can design by this. Input માં જે કેપેસિટર જેવું ડ્રો કર્યું છે, that is your switch input. Okay, અને જે બ્રેકેટ જેવું ડ્રો કર્યું છે, round bracket, that is your coil or output. So this one is your ladder diagram. Clear? You can design different kinds of gate using that. Okay. Same way, different functions also, and same way you can design any of the automation concept. Okay. So this is all about automation. एक software હતું, but simulation I don't think so you are interested. So we'll stop over here. Okay. Thank you very much.